Hello everyone, welcome to another Google Cloud session. My name is Suresh. So in this session, we look into the lab called Bracketology with Google Cloud Machine Learning. Okay, so this lab is around about 15 minutes. So in this lab, we are going to complete the tasks provided here, and we are not going to discuss anything theoretical or practical. So without any delay, we'll start. And to complete the lab, you need at least you need actually 5 credits. So that is what I'm going to use. So to buy the credits, it will incur some charges. For you, if you already have the credits, that's fine. But if you want to buy the credits, it will take some charge. I have opened the Google Cloud Console. So, so this is the project number and the Quick Labs ID. So everything matches good. And let's start working on this. So at any point, you can pause the video and go to the overview because I don't want to miss the time. So you can go through the overview of it. You can pause the video and get to the overview, and you can see what are all the things you can do in this lab. So this is a BigQuery and some in NCAA tournament data set has been provided. So for to complete this query, I mean prerequisites. So you can go to this introduction to SQL. Right, open this here. So we have to complete the lab. Okay. Also for the query console. Right, here you have to start. I have already both completed these two. So I think this is an option, not a mandatory, but for better just understanding, you have to go through this. So to start the lab, um, I have started the console, logged in, and I don't have separate terms and conditions. Okay, now task one. Let's open the BigQuery. This is the navigation menu and back to the here it's query. And we already have the lab, but there is a difference because I already used this, so I already know I have two more data set. So don't worry about it. But in the Explorer, we will use what is needed for us. Okay. Now NCAA March Madness. I will again leave this to you. If you open this link for you guys, no, it is not working. Both the URLs. Okay. Architecting live NCAA predictions from architecting insights and 2020 Google Cloud March Madness insights. Okay, there is a couple of URLs. Maybe you can go and search it over here. Okay, let's now, this is the dataset we will search. Now go to the BigQuery and you can click on add data. Let me search over here. BAA public datasets. Right over here. Okay, now I've got the dataset. There is this. This will open on the dataset. This one you can offline also you can say this. This is actually basically it is a BigQuery public dataset NCAA database. Just go back to here. I already have one, right? So you can add this by using add data and star a project by name. Here you can mention as BigQuery hyphen public hyphen data and click on when you click on start, the moment you click on start, this will get loaded here and you can also search it over here. Let me show it over here. EFG IGPLM. There are a lot of information. Okay, so basically this is the idea. You can get this from this location. You can see if okay, this is after the creator side. Okay, you can see BigQuery NCAA basket. This now you can see tables. Now you can see inside this there are 10 tables. Okay. So this is how you can verify. Okay. Let's click on MBB historical tournament games. We'll then click on preview. Okay, in the preview, you get the data. I mean, you can preview the information, and in the details, you can see the metadata about it. Okay. Now, write a query to determine available seasons and games. So you can pause the video and understand about this. Let me copy the query first, and let me close this and then go here and run the query, and I will toggle this better viewing position. Now we got the query, games per tournament, and along with the season. Okay. Let's check the progress. Scroll through the output and take a note of amount of seasons and games played per season. Just make a note. I'm not going to note it, but if you want, you can have a note about it. And let's test how many NCAA basketball seasons. 85, 86 are available to us. 85, 86 is 16. What? 1985, 1986. What I'm trying to say is this is 67. I really don't know what it's about. How many NCAA men's basketball seasons? Oh, 33. My bad. Total number of rows is 33. Okay, total 33 seasons. How far back in time does the data NCS? Far back is, you can see 1985 as well. Yeah, 1985. Uh, Understand the machine learning features and labels. You can pause this video and understand this content. Let's try to understand this. In our historical data set, we know that correct answer of our labels. We want, no, you know who won or lost. Oh, that is the reason we have to go and see the data set. Yeah. So in preview, import, loss or ties. You can see this wins and losses. Yeah, we have the data. In future prediction, we know the correct answer of our labels at the time of predictions. No, we will not be able to predict the correct answer. We will not be able to predict only probability answers. Okay. Create a labeled machine learning data set. Okay. From the left-hand menu, historical data is configured. That is what I have done without knowing this step. Okay, fine. MBB historical in games, tournament games, and in sessions, tournament games. Okay, I click on preview. Have this information. So it's resembling the following: through season, round, days from epoch, date, day, win, lead, win region, win market. Okay, just to understand. Our labeled column for the outcome, the game already exists as a column in our dataset. Let's check the details. Now schema. So false, right? So for each specific basketball game, the dataset has one row for winner and one row for loser. We go with this. After the inspection, you will notice that one row for has both win market and lose market. You need to break the single to each winner or loser. Okay. Now let's run this query. So we take a new query, paste it. This is a very big code. So let me, what I will do is like you can pause the video and understand the statement from line number 1 to line number 28. So one snapshot you can have. Let me scroll down line number 29 to line number 56. Okay, let me run this code. This will be quick because we see that only in KBs. So now we can see query is completed. Let's check the progress. Why should not we use the points, scored, win points, and as a feature in our training set if we have the data available? That's a good question. This is also correct. This is wrong. Okay. Now, create a machine learning model to predict the winner. What type of machine learning we should be knowing? Classification, because win or lose, this is not a number like uh, predicting what I would say spam or NAS. That is a kind of. So this is not predicting how much it can go or a series. Okay, choosing a model type. I will leave again. I want you to pause the video and go through this. and understand what is logistic regression, because this is a classification model we are trying to predict. If it is a linear regression, then it will be like now. Let's go back to creating the model. So here in the Explorer, this is the project ID. To navigate to the tab, close this. This is the project ID, and now we will create a data set for this. Create data set, and you name as bracketology, and we can leave other options as default. This is going to be a multi-region, and in the advanced option, manage keys, and all this information I will leave it as default and click on create data set. Now again, let's use the SQL query here. App. Now again, this is a very big query. So this is going to process. Okay, now you can see from line 1 to, we pause the video and go through this from line 1 to line 22, and from line 24 to line 43. So this is the complete view. Basically, we are going to create a model called NCAA model. So let me query. This will take a few seconds because this is just some 20 or 30K. Creating a model in few lines, one of the most important options. Okay, we know. And this is going to be a logistic regression. Let's wait for the query to get completed. From there, we can go to model. Let's check the progress. This model will be visible over here. Okay, the query is completed. So let's see the Explorer. Let me toggle the Explorer. Now model is ready. Let's see the job information. It took about 48 seconds for 76.6 KB and build is 10 MB. And execution details 46 seconds. Times not consumed. These are all the other information you might need. And the execution graph, we can see the execution graph at each stage. Train and event. Total force will be so. So let's go to the results. Let's go to the model. This model is actually available in these models of bracketology and here NCAA model. And here model, you can see all the metadata related to the model. Okay, and in the training with respect to the table view or in the graphical representation, and you can see the learning curve, loss, and duration. And let's go to the evaluation. And these are all the metrics. I'm not going to explain all these metrics over here. I want you guys to understand or to do your reading, learning on for all the each and every metric. Just one thing I will show you here. When you change, see the threshold, and you can see the graphical is also getting changed based on that. And all has some inference to it. And I better recommend you to go and understand for the other various sources. And also, here is the confusion matrix. You can see toggle between the number and percentage, and you can see the true, positive, and true negative side, false positive, false negative. And let's get to the schema. And this is our predicted table, whether win or lose. And these are all the seasons and other features that we have. Let's check the progress now. You can see there are some ML options model. Okay, so right now we have used linear, not linear, logistic rate classification model. There are, for the regression, there are multiple model types. For clustering, and you can, I mean, you can go on and on. Fine. Let's move on to this. Now I'm not going to go through all the reading stuff here, and I want you to go and understand. This is overlooking another important concept. You can learn it on your own. Your model training starts. Where can you go and see this? I have the model. This is the NC model. Okay. I wanted to see the model training starts. We know the training data. Okay, here it is. Hmm. This is the class. I think this is the older view from the left side. The right side we have the iteration, training stats as well, and see the model learned about our features. Okay, let's get into this. Another query based. You can pause the video and understand what this query is about. The query, resembling this. Okay. As you can see, syntax meet documentation. Okay, so wait functions. There are a lot of information over here, and this. Now we will evaluate the model. So you can see evaluate model, bracketology, and CAA. You can see the precision, recall accuracy, F1 score, log loss, and ROC, AUC. Looking good. The value is around 69% accurate. This is very, very important information, guys. I want you to pause the video and go through this information. This is let me copy this farming also. Okay. So each metric, what it means and how to use this. Okay. Now, what do you think we could do the improvement of our data looks at the tournament, which is small part of the table. Ah, okay. Next one, we're adding more features. This is a good option. This one is also a good option. Instead of that, the total points go to the total game and the trading. I guess. Making predictions, good. Let me take a new query. Paste. And here you can see ml.predict from the model. And let's do the run. The prediction. The query. Okay, now go to table. Once we click on the table. Okay, why would you bring back the data columns to win points, and around particular? Isn't that not allowed? The model is already using it? Okay, now we can see from predictions table, there is a probability table. I mean, wait, how many did our model get right for 28? Let's see this. Let me remove this. close this query file. This latest query and run. Why? We need to run. My bad. Run. And we got win and lose. Predictions probability 79%, 20% for the season 28. Predicted label round 68. And there are some other additional information. Okay. So out of 134, 70% of total revenue. So we can take use of. Okay. Let's run this query now. This is the complete query. Let me. The model predicts seed 1 Virginia to beat seed with 87%. Seems reasonable. Okay. Let's recap because we already crossed 11 steps, right? So these are all the things we have to without using seed and team name features. Okay, let's do that. Now we will create a second ML model. And this is all the shortcoming. I want you guys to pause the video and understand what this query is. Now you can see there is a training and new features. This is going to be a table. Okay. This is about hundreds of lines. Okay, again, what I will do is like I want you guys to pause the video and understand this query. So just pause the video at this point and go through this line number 1 to 20. Okay, and next set is line number 21 to line number 39. Line number 21 to line number 39. Next one is line number 41, 41 to 52, 54, go through the 54 to 80, 82 to end of the line 97. Okay, looking good. Now run the query. Let's check the progress. Query run completed. Let's check the progress. Now click on go to the table. The results. Okay, let's go to the table. And here in the preview tab, we have the season label and all the seed and the required details for us. And interpreting selected problems. Okay, I want you guys to pause the video and go through this information. Okay, opposition, efficiency rank, opposition pace rank, and now train the model. The model is getting updated. That means we are going to train a new model here. So let me do this query. Okay, same method. We'll go through this from the line 1 to line 25 and line 26 to end of the line. Run the query. Query is generated. Let's get to the model. Once it created results, again this is going to create a new model called updated model. Instead of model, we will see this. Now creating model takes typically 2 to 3 minutes. So let's wait. And you can see the model is created. You can see the model has updated. Okay. Now you can see the go to model. You can see the information regarding the model. This is the new models, updated models metadata and training data and evaluation criteria, metrics, score threshold, and the schema. Okay, so we close this. Okay. Close everything. So let's have a cleaner view. Okay, now evaluate the new performance model. Now we will evaluate. And you can see the precision recall accuracy of 1. You trained a new model with difference and increase your accuracy from 75 or a 5% lift from original model. Check the progress. Inspect what the model learned based on the weights. Let's see some order. So you can see the weight is also listed over here. As it is the top 3 pays staff difference, efficient staff difference, and efficient date difference. I want you to pause the video and go through this content. Now this is prediction time. Okay. On the query. Okay. Prediction step. Let's go to the table and we can see it in review. Check the progress. So now from the label, we are going to predict the label as well. There are results we got. And you can see some inference also provided here. Where were the upsets March 2020? Let's look into that. 25. Let's run this query. And you can see the results over here. And task 21. Comparing the model performance. Okay, let's compare the model performance. So you can see a predicted label, probability, season, seed, pool arena. Okay, predicting the 21 Madness tournament. Task 22. North Carolina, Gonzaga, Duke, and Virginia. Okay, now this is, let's create a matrix as well. Again, guys, I'm just running the queries. I'm not getting into the details. It's your responsibility to go to the queries and understand the details. I'm not here to explain the query and what it gives. Okay, that will take more than 5 to 6 hours to complete this one exercise. Okay, now this is a possible. Team Kentucky will go with and opposition seed is 7, and this is some information has been provided. You can filter it out and understand it. But we have about 4,000 plus information over here. Okay, now this is the team stats for pace and efficiency. Let me go to the query first. Okay, so again go to from line 1 to line 14, one snapshot, and yeah, line 1 to line 24, one snapshot, line 27 to line 55, second snapshot, and next one is line 57 to end of the line. The query. Now you can see how fast the query can be executed with a lot of. Okay, so now we have the table as well. Now this is a new table of the tournament. You can see the preview if you want. Okay, so now let's make the predictions on the new table. So table, now in the table, now let's do the predictions, and you can see, let's go to the table again. Now we have the second predictions as well for 2019. So let's check the progress. Now in the 2019 predictions, just run the query, and we can see the prediction and its confidence levels between the school and the opponents of. Okay, these are all predictions. So Q1 85% favor to be North Dakota. Okay. I know this is very boring class session because I'm not here to explain the session. I'm here only to showcase how this lab works and what is the queries. If you pause the video and understand it, definitely this is really a good project for predictions. Okay, and also very good machine learning project. Okay, so that's it. Time to end the lab. Thanks for joining with me and have a great day.